Hi, so this is just a summary or a recap on capacitance and how it is used to measure the water content of soil. So the overall term is called frequency delay reflectometry, sometimes called FDR, and it's this mechanism that is used through capacitance to measure the soil water content. So capacitors are used to store electrical energy in an electrical field. So if you remember from high school, maybe you've got a circuit like this, and you have a capacitor in your electronic circuit. So this in the middle is called the dielectric medium, and it has a dielectric constant. It's when it's connected to a battery like this, your current will flow through your circuit and get to your capacitor, and then you'll have an energy field or a charge, usually a positive charge around your capacitor. And so this principle is used in soil science to determine the amount of water in soil, because for soil you have a specific dielectric constant, and for water you also have a different dielectric constant. So during this capacitance measurement, the dielectric constant of the soil is measured, and so electrodes are placed in the soil so that the soil then acts as the dielectric medium. I know in some devices that they use, instead of putting the capacitor like this or in that position, they'll actually let them face upwards. So instead of being parallel to each other like this in the circuit, some of them actually prefer to make this then the medium. So the current flows through the electrodes. So in measuring, we've got a current that flows through this circuit, and the circuit then being the device used to measure the soil water content. And it is used, so the soil then becomes charged around your capacitor, and then that soil, or that charged soil around the capacitor, is measured in order to measure the capacitance of the soil. And then if you have that capacitance of the soil, you can determine the soil water content. So I've had questions about the diviner. So how the diviner relates back to measurement of capacitance, or FDR, is the diviner 2000 is just one of many devices that soil scientists use to measure the soil water content of soil. So if I can just show a picture. So here's your probe that you put into the soil. That is your capacitor, and then you also have a screen or a data logger. So it's a handheld soil water monitoring device. You've got your portable display and data logger, so that's over there. You've got an automatic depth sensing probe, which is this probe, and then you've got two electric rings forming a capacitor. So there you've got your capacitor and an oscillator. So what an oscillator is in this case, it acts as a battery, but an oscillator is used to send an electronic signal. So sometimes it sends waves, electronic waves. So basically, if we're looking at this, you have your current flowing through your capacitor, and it's causing a charge around this capacitor, so a positive charge like this. And this oscillator sends out waves, so it sends out energy, and because it sends out the energy, it causes a charge around the soil like that, or around the capacitor in the soil, and that is then picked up by a sensor. So it picks up the charge around the capacitor. In other words, it picks up what the dielectric constant is of your dielectric medium. So the medium is the soil, and that then determines how much water you have in the soil. And so the advantages and disadvantages remain the same as the previous slides. Non-destructive, so you can measure at the same spot continuously. It measures the volume of water, and not just the matrix potential. It's very accurate. The disadvantages, the electrodes must make contact with the soil, because remember, air also has a dielectric constant. And so if you are going to put a probe like this into soil and it doesn't make contact with the soil, it will measure the air instead of the soil. The salt content can influence the measurement, and they are really expensive. Okay, so next up, I also had a question about using your A pan to measure the amount of evaporation. So I'll quickly do this example again. So you have your A pan in or in the air on your farm like this, and you have a scale. So this scale measures as the amount of water decreases. You can see on the side the reading will also change on this scale. So let's say, for instance, it's 100 at the bottom and 0 over there. So usually you will try to keep this the value for this scale close to 50, because if it's 100, it means that all the water in your pan has evaporated, and if it is at 0, then it means that your pan is full. So maybe too much rain or something like that occurred, and so you won't measure accurately anymore. So what happens here with the difference water level before regulating and the water level after regulating. So on day number 4, the water level measured was 112. And so if I can maybe change this, then say the maximum that you have is 120. It means that as soon as this thing is empty, you'll have to fill it up again, otherwise you won't be able to measure the amount of evaporation that occurred during that day. So if you see that little asterisk sign next to the 48, that means that the water was added, or maybe if it's full, that water was taken away. So that's what's meant by before regulating and after regulating. So if I can go through this example, so on day 1, you had 50 millimeters in your pan, so we'll write that. Then day 2, you had 72. So from 50, which was maybe here, it dropped down to 72. So you want to know how much evaporation occurred. So you'll say 72 minus 50 divided by 2, and that equals 11. Okay, so on the next day, so after regulate, or while you are busy with your calculation, you see that 72 is still fine. So you don't need to regulate the amount of water in the pan. So you leave it at 72. The next day, it's 97. So you do the same. You'll say 97 minus 72 divided by 2. And that'll give you 12,5. And so it continues. So now on day number 4, you get to 112 and you realize that it is going to be too empty now for you to be able to measure effectively on the next day. So you top this thing up with water again, and you get to 48. And that is why we have two different columns for before regulating and after regulating. So just to get back to this one, so you'll take that 112 and minus 97, and that'll give you a value of 7,5. So now you have 7,5, and then day 5 you'll take that 48. If this is 72 again, then you'll take that 48 and say 72 minus 48 divided by 2. It's 12. Okay, so then you have 12 for day 5. And that is how you calculate the evaporation for the class A pan. But that is also why you have two different columns for before regulating and after regulating. And that's why there's a difference in value for after regulating.